Hello everybody, my name is Jessica Mays. I am a scientist who recently did an experiment studying how the polar ocean arrays have helped us collect data on the surface chlorophyll volumes. What that means is the surface chlorophyll volumes help us to identify the abundance of phytoplankton in the ocean arrays. There are two different ocean array possibilities that we could have chosen. The three that I have chosen today that I decided to study is the Station Papa array that is located in the North Pacific off the Gulf of Alaska, the Southern Ocean array that is off the tip of Chile, and the Erminger Sea array that is in the North Atlantic. Now these three arrays have these three triangular moorings that collect data continuously throughout the entire year. Now this data has helped scientists collect information on these spikes and volumes of the amount of phytoplankton on the surface of these waters. Now phytoplankton are considered single-celled algae that undergo photosynthesis. And why would that be important? Well, phytoplankton actually is probably the number 2 or number 3 producer of oxygen in our entire planet. So they are extremely important for data collecting and extremely important for finding where they're most abundant. And I believe that these three moorings or arrays have helped us identify where we can see the spikes, where we can see the blooms, and where we can see where our problems might be and what we can do to kind of help either solve it or kind of figure out what our next step is. Now, information on collecting the chlorophyll data. The three graphs, one of them, if we're looking at the North Atlantic Erminger Sea array, you kind of see like a wavelength. You see a really big spike in between April and July that kind of looks like this massive tsunami, not a tsunami wave, because tsunami and tidal waves are completely different. But you see kind of this huge, let me see if I can actually get back to it for you. I cannot. But anyways, if you kind of follow this little arrow, if you will, it kind of goes like this. So now this wavelength kind of shows that there was a big spike in phytoplankton production in between spring and summer. And now what that means is that in the North Atlantic, winter months are relatively light deficient. It doesn't have a lot of light. However, the waters are always cold and all the nutrients in the water are relatively mixing well because the thermocline is not very stratified. I'm sorry, I cannot say that correctly. So the mixing of the water and the nutrients is always moving. So there's a strong amount of nutrients in this system. Now when spring hits and the light hits at the same time, this boom of light, this boom of nutrients causes this huge amount of phytoplankton production and causes this mass amount of phytoplankton to show up in this graph. Now, you might see the zooplankton graze on all of this phytoplankton, kind of deplete most of that off the surface. Now, the only reason they have another bloom in the autumn, not unlike the Station Papa array, which I'll get to again, is because there is another small source of light and nutrients that do another mixing, which cause another small bloom. Now, in the Station Papa array, this is a more temperate region off like the southern, like more California kind of area. So the seasonal changes are a lot different. So you have light deficient winters, but not nearly as bad. So you have light deficient springs and not spring and summer. You have not light dependence. I am searching for the wrong words. So you have this strong amount of light between spring and summer. You have a limited amount of light, but not nearly as limited as the North Atlantic. So you have this seasonal various change. So you have like, if you follow the arrow, it's kind of like a small spike in the spring and summer, and then it kind of spikes in and out, in and out, in and out. And what this means is that because of the temperate regions, temperatures don't really change all that much. They still change, but they're not the drastic change that you would see in the North Atlantic where you go from -degrees to frozen solid cold ice to, completely melted 90, 70 degrees humidity. So the seasons at the station papa are different. So you see definitely different spikes in the phytoplankton bloom. Now, the Southern Ocean Array, which was actually suspended back in 2015, I believe, doesn't really have a whole lot of data. It's just a straight line. And what this means is that there's just sun hitting it all day long. So there's light hitting, so there's plenty of phytoplankton in the ocean. There's no doubts of phytoplankton, but the nutrients at the bottom, the cold, rich, nutrient deep water is not mixing with the top. So there's no upwelling. The thermocline is so stratified that there's severely no mixing of the waters to help the phytoplankton complete primary production, complete this. So the Southern Ocean really didn't give any data, so they suspended it. So these were kind of like all the results. The only similarities I kind of found between the two, or the three arrays, was that the Station Papa array and the Erminger Sea array kind of had the same kind of like little wave kind of idea, where there was a big wave, not necessarily big at the Station Papa array, but there were bigger waves in the spring, summer, where the light had just come back from the winter months into spring and summer, and then another one in the autumn. And that's, like I said, it's most likely due to the two key factors, which are light and nutrients that phytoplankton and primary production need to thrive. Now, the only other questions that I would probably have with this entire thing, it makes me wonder why these graphs are so generally, it seems like they're very much pre-designed. There's not really any wiggle room for possible storms that could happen. I know climate change is happening a lot lately, even though a lot of people deny it. So what would happen if you had this really heavy storm that happened in the North Atlantic? So not only would you have nutrients, you would have the humidity in the air, you'd have temperature changes, which could possibly cause a phytoplankton production, could cause a bloom. Also, like in the coastal oceans, if all of these arrays were closer to the coastal waters, because phytoplankton live not by the shoreline, they live for the surface near the shorelines are closer to the sunlight. So I think that all three of these arrays might see bigger spikes in phytoplankton production being closer to the coastal waters due to this being closer to the sunlight and the surfaces. And that is really the only question I really had, is why are there not these variables happening? Why are there absolutely no variables? Why is the seasons not changing like we are seeing in other parts of the world? So, they're saying that the ice caps are melting. They're saying that a lot of the climate is warming, yet there's not really any kind of change in the phytoplankton production. So I want to know where this data is coming from and why is it not changing with the weather, basically. And that is my presentation on all of this. You can look at the entire poster that I posted on my website, and I thank you for listening. Thank you.